world, and where we don't have the luxury of having cloud backup all the time and looking at some real world decision making happening at the edge, then of course distributed intelligence will also work. So this is, if you like, is the foundation of for us to lay on top the artificial intelligence and machine learning capabilities into industries and other applications. If I look at the building blocks of collaborative robots, so as I said earlier, if you look if you read in the press, mainly when we talk about collaborative robots, people think about, a task that's being done, simple tasks. You see some cleaning robots and others. It's actually much more than that. The collaborative robots can actually perform very complex tasks and actually can have all of these building blocks. You can have a robot which is have a complete vision processing capability to be able to either work on let's say on a production facility looking for defects, have different types of sensors if they're maneuvering around the factory floor, of course different motors to help with the movement and executing different parts or different access control. And of course, where we talk about robots, where we talked about collaborative robots which are working in collaboration with humans, the functional safety is paramount, right? And of course that's also a key blocks. And then because you are looking at a distributed intelligence system, you need some sort of scheduler, some sort of real-time operating system. So like a ROS, which is a robot operating system, can also come into play here. And then what you see at the bottom end of this slide is where the robots are actually being intertwined with the function for high-end functions to interact with humans. But also you see the implementation or integration of what we call as MES, which is manufacturing execution systems. What the back end or the control system, the upper system, what you see on the left hand side here, are being deployed to control the factory automation, to set up the tasks, to monitor. And so basically they are being backed into those MES system as well as of course any of the communication system control and human machine interface as well. So collaborative robots can actually perform a lot of complex functions in the factories and the industries at large. If you look at it from a Renesas perspective, we have been a major supplier to smart applications across a whole host of industries. We are a leader in the microcontrollers and microprocessor space. Just to give you some facts, we ship something like 10 million microcontrollers every day across automotive, industry, and other areas. So we really have a lot of experience when it comes to different building blocks. If you look at security, for example, which is a key building block of robotics, we have been a pioneer in this, from a transaction security all the way up to security you've seen in automotive industrial. So security is a key building block. As I mentioned, that especially when you have the communication, right, which is from edge in end nodes to robots or other areas, you need to protect the data that's being transmitted, but also you need to make sure that especially where some real-time sensitive applications are being deployed, that these there's obviously a risk of perhaps these robots being compromised. So security is really important to really future-proof that aspect. Motor control, we provide a whole host of microcontrollers, microprocessors, and software support, and really where we are reduced, down to real high performance, down to 0.8 microsecond motor control cycles, which really means that the robot is able to execute at high precision the task in a factory environment. And the industrial network, so Ethernet is the backbone, and of course real-time Ethernet is the way to go. But we also provide support. We have products with the real-time Ethernet controllers, and as well as support for the legacy system. And in terms of functional safety, this is, as I said, a key building block. What we do at Renesas is to provide not just the security in hardware. So we provide the peripherals for ADCs, for different digital peripherals, etc. Where we have, coupled with that will be the safety software package and documentation. And the idea behind this is to reduce the time to market for the customers. when it comes to implementing functional safety. So really, my message behind this slide is if you look at what I mentioned here on the previous slide, that we really have all the building blocks when it comes to designing different robots applications. Let me go a little deeper into the functional safety aspects, right? And why that is important. I think as consumers, as people, going through our normal lives, we know that intrinsic safety is very important. So think about a road, right? You got cars running in different directions, and in this case, if you look at it, we put an overhead bridge, to avoid any collision from the cars on the main road. So this is really intrinsic, ensuring that there's safety in place. When it comes to the, real system level security, functional safety in industrial applications or even others, what we basically say is the adding safety function to ensure the safety at an appropriate level. So think about that, this junction on a busy road where traffic light is acting as that safety function, right? So if you think about that analogy, if you apply this to the industrial space, think about this. Now on the right hand side, you can see actually an industrial robot who's driving a motor, and it is, has its own independent controller, and it's important that that this big robot is not able to harm the humans or even destruction of equipment or also the machinery, right? So you put a monitoring equipment, and basically what we're doing this is to be able to monitor any abnormal behavior, or and as well as to, if you think about the AI implementation or even having the back-to-back functional safety features in place, this means you monitor and take countermeasures. For example, if the motor itself has a certain, imbalance, or the robot itself has some anomaly, right? So the monitoring equipment is in ensuring there's an adequate level of safety being implemented in terms of the whole system. So I think it's a good way to understand why, especially when you talk about collaborative robots, it's important that we have the functional safety measures in there. Okay, the next thing I talked about is the IoT and OT convergence, right? In the past, if you think about, the factory had an island of network, right? So it couldn't really access the corporate office or have real-time communication with the back end, right? So really what's happening with the IT and OT conversion is allowing what we call, is open communication and real-time communication. I remember I talked about the MES, right? The manufacturing side of the system, which is actually basically the control systems or the management system in place. So, in the case of industrial automation, you will have the OPC Foundation, which stands for Open Platform Communication Standard, which allow this, transferring of the data from factory floor to support the MES, or even think about the data lake or the cloud connectivity, right? It's important that, there is that two-way communication. So the convergence of the IT infrastructure and the OT infrastructure is really allowing the evolution, of course, the establishment of Industry 4.0, but moving forward in the next stage of the industrial revolution is really also helping as well. Here's a good example: is the technologies to support is like TSN, which has the native support for OPC, right? And similarly, on the factory floor, you can have, EtherCAT or Ethernet IP or Profinet. So these are, of course, the industrial, communication standards that's supporting the whole network. So the message here is that for the whole evolution to take place, it's important to have this convergence. And one other thing is, if you think about also the implementation of artificial intelligence and machine learning, there also you need the support of OPC in this case, right? Of having this open platform communication to be able to, have that system which is communicating in a good manner. Let me now move on to, it's a good segue into artificial intelligence, right? So, if you look at the AI space, you're basically looking at the three different types of predominantly three different types of AI technologies. You have machine vision. So basically, you have applications where you're having, looking at the images or access control, or looking at the health of different machineries. So taking some vision data and then applying a certain level of intelligence to look for anomalies. The second part is, of course, voice, right? Where we're going from, basically simple command to more spoken words and natural language understanding. The third one, which is really popular, especially when it comes to robotics and industrial space, is what we call real-time analytics, or sensor-based intelligence, or time series-based intelligence. At Renesas, we recognize this requirement, and we actually have established a AI Center of Excellence as part of our acquisition that we made, a company called Reality AI a couple of years ago. Where we look at different if we look at different signals. Basically, we can work with any high frequency signal and take that data. We have the tools that helps to categorize that data, label it, and depending on the accuracy. So remember the example I was showing you on the previous slide about the different motors. So let's say looking at a motor that's driving a machinery in a chemical plant, for example, if there is an accelerometer, some sort of sensors on that machine looking for vibrations or looking for, unbalanced conditions, we are able to actually remove any of the external sensors, look at the voltage and current signals, and to be able to make a prediction and actually provide the intelligence into the system. So it's an AI, it's a completely automated tool chain which helps you to then develop the model, and then we integrated this into our embedded development environment. What we have an IDE, E Squared Studio based on Eclipse, where you can actually bring in that model import that into your embedded workspace and develop the application. So the key advantage for us is that we are providing very tiny resources, so we can implement this on a very small flash, RAM, and maybe less than 5 or 10% CPU resources. So our message is that you can actually implement machine learning on your existing hardware, right? So real cost saving. Also, the tool itself is able to give the intelligence on the placement of the sensor. So basically, instrumentation side of thing is also covered, right? So really providing a complete solution to be implement a highly efficient machine learning models to detect different types of anomalies across a range of applications, and it can work any of our microcontrollers or microprocessor. One last thing which is very important is predictability. A lot of the AI tools that are out there are a black box, right? But in real application, like we were talking about robots, you want to be able to predict, have a deterministic behavior of the model that you deploy real time on a factory floor or another application. So the tool itself has the explainability built in, where you can actually trace and see at any point of the model execution is what the model is doing, and have a deterministic behavior of your machine learning model. Let me now dive into security a little bit, right? So we did talk about the security, requirements, and the key areas that you're looking for is to be able to detect and have a secure boot implementation. That's the bare minimum baseline implementation, where you detect the bootloader, and any firmware tampering will actually prevent the device to actually boot, and have that mechanism in place to make sure that the firmware that's been actually downloaded on a particular edge device is actually being run. And then in terms of the encryption support, so in our devices we have the RZ T series and the N series. We have a crypto accelerator, right, which really providing a whole host of functionality. For example, if you have a true random number generator, meaning that when developing let's say a secure key mechanism, right, you're able to do this in a highly robust fashion. And the storage itself is also highly secure as well. We have a memory protection unit in place, for example. And the other thing is, the secure updates, right? To be able to The way the Renesas secure crypto hardware works is that decryption actually happen within the device. So you have a public-private key pair mechanism where you provide a public key for if let's say your maintenance people or the backend office to update a firmware on the device, and inside device you have the private key, and having that the mechanism public-private key pair, the actual decryption will happen within the hardware as being living highly secure. In addition, our devices, RZ devices or RA devices, has the trust zone capability that comes as part of the ARM implementation as well. That basically separates your secure and non-secure part of your code, right? Providing an additional level of security as well. And of course, finally, the debug is important. We're using the JTAG protecting against any unauthorized access to the debug port as well. So a very foolproof, highly secure mechanism backed by security in hardware with the software libraries provided as part of our baseline software. Let me dig in a little bit more into, we talked about vision, for example. So in terms of vision processing, we have our RZ-V2 series, which is what we have is the DRP, it's a dynamically reconfigurable processor, which is actually an accelerator that helps to speed up the AI-related workload. So imagine in a vision application, you have either moving images or different types of graphics you're trying to manipulate and analyze to be able to detect some anomalies. You need the performance, right? So this device, has highly capable multi-core CA53 cores, ARM core inside, as well as this DRP accelerator. The other thing which is very important, a lot of the products that's out there, the GPU type of products that are out there to implement Vision AI needs a very, very complex and very intensive heat sink, right? We can actually do this at a very low power way, and the device is designed to support low power implementation, eliminating any cooling fans or any heat sink requirements, really providing a very sustainable AI solution. Functional safety, I mentioned already, we have, we provide free of charge SIL3 certified self-test libraries for all our MCU and MPU. We're also providing certified network application software as well. So really what we're trying to do here is customers to focus on their applications and speed up their functional safety certification for their end product by having these functional safety assets that we provide as part of our hardware and software. Of course, ultimately they have to certify their application. So really a very comprehensive solution. And the last part of the blocks is communication, right? Remember we talked about real-time communication. So our RZT and N series, really it's an integrated controller which is providing all of those four building blocks in one device. Basically, you have a solution. If you look at TNN, you have a motor control peripherals having a very capable PWM output. For example, we have a whole dedicated security engines. We have dedicated functional safety peripherals on board, as well as that can in a safe manner interface to an external safety MCU in this area. Also, we have the encoder interface to providing a complete motor control solution, and finally the industrial network support. So we support the industrial Ethernet, including the TSN switch that's inside this device. So really providing a real-time communication across a whole host of industrial protocol, whether it's Profinet, it's EtherCAT, TSN, or even more. So my message here is a complete integrated solution, reducing time to market, and I always say reducing time to revenue. Finally, on the voice recognition side, so certainly we're moving away from simple commands, what we have in the house, to be having more robust solutions, right? Certainly as we post-COVID, right, you're having more and more voice control based applications, and so through our microcontrollers we can actually have our internal peripheral, whether it's A to D or internal I to S interface that can connect on to the mics, and the audio equipment, providing working with our partners, in this case, Cybron and others, providing a voice recognition processing, right, where you're actually able to either train a command. And but the important aspect of this is working in a noisy environment, right? Working with the RF signals around it. And also we provide support for 40 plus languages and different accents as well. And other important aspect here is the voice anti-spoofing ability. So somebody to, especially in a security application, to make sure that nobody's trying to hack the system by spoofing the voice command that you put in place. So we're providing complete ready-to-go kits and solutions that enable again customers to implement voice recognition solutions as part of their application. We extend the support, so we're very proud of a very comprehensive ecosystem in place. It's all about having these different building blocks. So let's say communication side of the things, there are multiple different protocols that can be used, right? So you have we are part of like PORT, TMG, or TE Concept, working with our partners to help them implement maybe IO Link or TSN or other type of protocol support, right? We do provide a proof of concept for the ROS, the robotic operating system, and again we have some partners in this area who can help the customers to implement this in the end application. I talked about voice recognition already. We have a DSP concept, a Sensio Cybron, who can actually help you to implement a very robust voice control system in your application. But more importantly, they're optimized for Renesas devices, which means the actual resources that it really have been highly optimized to take very minimum resources of the controller as well. And in a similar fashion, HMI, there are a whole host of partners that can help really enable the solutions for your applications. I want to now come towards the end and talk about an excellent partnership we have in place with RT Thread for expanding for a number of years now, where we're working with them, of course, in China, but across the other areas as well. One of the good example I wanted to bring to your attention is the RT Thread has developed a vision board based on our flagship RA8 D1 product. So RA8 is the leading product, the only one product in the market with ARM M85 implementation, which has the dedicated graphics control on board, but also the security implementation I was talking about, and finally the Helium, which is an AI accelerator included inside to speed up some of this vision application. It supports the MicroPython. I know Max was talking about some book earlier on about Python. It supports that. LVGL, which is providing the GUI libraries for the backend, supports the TensorFlow Lite, and the Tiny USB support. It's a very comprehensive solution. The board is available, ready to go to implement a number of applications in the vision space. Also, providing the complete hardware software integration, where if you start from the bottom, you select the MCU and MPU that you need. In this case, it could be any RA device, which is our microcontrollers family. We have our flexible software package, which actually provides the low-level drivers and also the middleware for different file systems and networking stacks, networking interfaces. We plugged inside the RT Thread software package as well, which have the complete enablement in terms of some of the applications I mentioned. As well as if you look at the user application side, we have the LVGL support. So this is where you can have a HMI solution for JPEG, TFT with a MIPI interface that's natively supportive in some of our products as well. And finally, we provide lots of production ready drivers that will help you to speed up. So we're not providing just the hardware, but complete software framework to speed up your time to market. At the bottom end, on the right-hand side, soon you'll be seeing, a complete networking stack and the industrial networking support that I was talking about rolled out in the mass market. And finally, the whole ecosystem with RT Thread, we extending, RT Thread, with us is providing a lot of reference designs, whether it's low power implementation, different tutorial to get up to speed, and different hardware implementation, as well as training. So, I really invite you to work with RT Thread to speed up your time to market across many applications. And finally, I just want to come to end of my presentation. I think what I've been able to hopefully illustrate is that there is a next evolution of industrial automation is coming our way. There is a lot of potential across a whole host of application. We're seeing, a very healthy CAGR, the growth rates in the automation market, but more importantly in the robotics market, right? And as we move into the next era of automation and also the implementation of AI space, I think this is going to give a lot of opportunity for us as silicon vendors to provide solutions for smart devices, but also our ecosystem and customers to work together to create this smart society. You've seen the key requirements, certainly when it comes to industrial space, the collaborative robots, the networking, the safety, functional safety, motor control, and of course AI coupled with security is the key building blocks. And it's important that and one of the challenge right now is we are not data scientists, right? Everyone, we're not maybe the RF engineers. So collaboration, the ecosystem has to work together to provide a complete solution. And hopefully, I've been able to also showcase that Renesas is providing all the key building blocks to be able to implement a very comprehensive, very robust, but safe robotic solution in a whole host of applications. And we're extending the support with our collaboration with RT Thread, where you have a lot of reference designs, application examples, and tutorials, and on the ground support to help you get to market quickly. With that, that's the end of my presentation. I thank you for your attention. If there's any questions or comments, I'm here. My colleagues are here. We'll be more than happy to take those.
Thank you, Mohammed. I was just about to say, if anyone's got any questions for Mohammed, please post them in the chat. I was watching this presentation, Mohammed, and I was thinking, good grief, how things have changed. Since I was coming up. When I started when I started going to university, the first 8-bit microprocessors were just coming out. 1 megahertz clocks, if you were lucky, about 5,000 transistors. We didn't even dream of an operating system like RT Thread. We just programmed bare metal.
Yeah.
And you see the sort of processors now that Renesas has got. It's phenomenal. And the AI and everything. And the whole collaborative robots is very exciting indeed.
Yeah, absolutely. I think the certainly as the more complexity is coming in, I think the use of operating system, having an intelligent scheduler to be able to have a more efficient implementation of your software is paramount. And also, I think it helps you to as you talk about functional safety and certification that you require for your application, it's helpful. I can see some interesting discussion going on the chat, and my colleague.
Yeah, I was just about to say PLCs. People are thinking of these great big PLCs and not and saying, can you use microcontrollers for industrial control? I bet you can.
Absolutely. Yeah, absolutely. So, I mean, the PLCs, of course, moving, also getting intelligence. I have industrial background. I used to work for a big industrial giant years ago, and we're all ladder logic, right? Now you talk about operating systems, we're all ladder logic, right? And now, of course, we're having more intelligence. So yeah, we have a whole host of microcontrollers and microprocessors to address that. And as I said, I think my colleague is busy answering, so he's saving me to take some of those questions. But again, appreciate the time. And we are here for another few minutes
Yeah.
if anybody has any questions in the coming sessions. But nevertheless, you have the context for RT thread, and Renaissance contact. We're more than happy to continue this dialogue.
Yeah, one of the things, well, first of all, I'm just asking Kathy to post the giveaway link again so that people can, if anyone new is in, they can enter the giveaway that we'll be having in the first break. We're giving away 5 development boards. One of the interesting things when you were talking, you were talking about the sort of sensors that we need to put on collaborative robots to protect the humans. So the robots that people have traditionally been familiar with, like in automotive plants, are these humongous robots that can pick up car engines and move them around, but they have no knowledge of their surroundings. And so we put them in a cage to protect humans, because the robot could turn around and crush a human without even
Correct.
noticing
Yeah.
he was there or she was there.
Right.
So we've got to make even a collaborative robot is potentially powerful enough to do some serious harm to a human. And one of the things that we do is put vision systems on so that the robot can see what's around it. But another very important sense is touch. And you were talking about accelerometers. And one of the things about an accelerometer, if you've got like a 9-axis, sorry, a 3-axis accelerometer, you can just stick it on the side of a motor or whatever. But if you want to get the sense of touch, that's a different thing entirely. And I
Correct.
was just talking to a company called Bota Systems, BOTA Systems, and they make force transducers for robots, 6-axis. So you've got, if you're pushing or pulling in the XYZ directions or rotating in any of the 3 directions, these sensors can tell you that. But it hadn't struck me, unlike an accelerometer that you just stick on the side of something, to detect force, these have to go, if it was a robot wrist, you have to
Correct.
cut the wrist off and put that sensor in the joint.
I
But
think I think Matt, you
that's very
hit the
exciting.
yeah, I think you hit the nail on the, these robots are no longer in the cage. These collaborate robots. They're working in partnership. Actually, there's a real interaction, right? So
Yeah.
imagine having this collaborative robot on a production line, right, where they're packaging something or looking for defects or something. There is also a human involved, perhaps doing the final check or whatever. So that's functional safety is really important. And all the sensors that you're talking about now, it means that you have to apply some intelligence. Is the
Hmm.
robot is picking up in the like a proximity sensing element of it, picking up something in its reach, and then what happens. So this is where I was explaining this. Our reality eye solution. We can implement those predictive maintenance on a anomaly detection using the data from those sensors that you decision also support the functional safety aspect. Actually, there's a
Hmm.
question here I want to pick up, and
Yeah, I
it's
was
is
the
the
robot
robot
operating system.
Ross? Yeah, is it becoming what I mean? What I would say is it's an emerging market. I mean, Ross is has its limitation, but certainly, what it does very well is the scheduling in those complex environment. But is it becoming a standard? I think the time will tell. I think what you will see also, from my experience, is that certainly on the industrial side, you need some more features for real-time communication. So yeah, I think it's promising, but is it becoming a standard? I think it's too early to say. What I would add here as well. Um, Another question is, will the computer vision AI application, industrial automation be a thing in the future since the progress in AI technology really? Absolutely. I think vision in the industrial space has a much, much higher value. Now, imagine an application, very, very high value application that being developed. The vision, based on certain knowledge, can actually provide a lot more intelligence for quality control. also measure well. Vision can also look at part of the integral part of the production as well. So absolutely, I think vision AI will become and continue to become machine vision a real enabler. But please also don't forget there are more sensors being deployed now everywhere. So real-time intelligence, what I call is real-time analytics, what I was explaining based on our real reality AI solution, is also skyrocketing as well, where you're really looking at predictive maintenance without the having the vision data, but having the sensor, high frequency sensor data to be able to make some decision. Hope that
Hmm.
helps.
Yeah, I think that's true. A lot of people, when you talk about sensing for AI, they automatically think vision.
Okay.
But you can, yeah, I have a background in automation as well, and you'd walk around a factory with an old engineer, and that engineer would, he'd hear something that worried him.
Mm.
And I wouldn't notice it, but he'd look around and he'd put his hand on a motor and feel it. And the combination of the sound and the vibration, and you go, this motor needs maintenance. Yeah, so it doesn't just
Yeah,
have to be vision, it can be all sorts of little
exactly.
clues.
So actually, Max, that's exactly what we do with our reality AI solution. We look at vibration signatures. Actually, what we have a solution called See with Sound, which we implement on AGV or automotive vehicles, where we can take different sounds and make either it's a it could be a sensor, sorry, it could be a siren, emergency siren. It could be, I mean, let me give you another example. Imagine you're on the road in a car and there's a jogger approaching on the junction. To be able to pick up that low level signal, we're able to
Hmm.
even offer those kind of solutions. So actually the sound is a major part of AI machine learning and AI implementation now, taking the sound, environmental sound, sensor data to be able to make those decisions. So absolutely vital information, replacing that human who's walking around the factory, hearing something and acting, actually having the AI deployed at the edge, looking out for those sensor data and those anomalies in terms of sounds to be able to make decisions.
I think one of the big problems at the minute is that there are like millions of embedded software developers and people creating embedded systems. And I think I read somewhere it's like 95% wish to include AI in the next product, but less than 1% actually have a clue about AI.
Yeah, yeah.
So,
I mean,
so they need to come
absolutely.
to companies like Renesas,
Yeah,
where to learn this stuff,
yeah,
and
absolutely. I mean, if you
RT
think
Thread, of
about
course.
Yeah, I mean, if you think about it, right, there is today there's the AI world and there's the embedded world. They kind of exist in a separate domains.
Yeah,
What we are trying to do in Renaissance is, to support those embedded engineers who are not data scientists, but they
yep.
know the real world problems they're trying to solve, and actually take the pain away and have the tool, this reality AI tool that we have is help them to actually automate some of that process, taking that data. You actually predict, you actually define what kind of accuracy you need to predict this anomaly or the other, and the tool actually gives you some options, right? So I think
And
I
very
think
often they've already got the data. They've been collecting the data for years, not
absolutely,
knowing what to do
absolutely,
with it. Now,
yeah,
now they
yeah,
need to be taught, how do you take that data, mine it, filter it for noise, and then use it for, like you say, predictive maintenance to spot anomalies in the future and so on.
absolutely, absolutely. Well, I appreciate the interactive discussion and
Yeah,
all the
no.
questions.
And
So
one thing I was going to say, if anyone out there is interested in knowing more about what Renesas are doing and the devices and the software solutions, software stacks, and everything, then please feel free to reach out to Mohammed via email and his colleagues, and they will be delighted to tell you more.
thank you very much.
Thank you, Mohammed. Very much appreciated.